with guidance. Today in this video, we'll be covering the section 4.3, the particle model of matter. Just to remind you, for your paper 1, we need to do the topic of energy, electricity, particle model of matter, and atomic structure. And this video is focusing on particle model of matter. All the other sections videos are already uploaded in a channel, so do check them. Now, in this video, we'll be looking over the density, changes of state, internal energy, temperature, specific heat capacity, latent heat, particle model, and gas pressure. So let's begin. Now, what is density? If you remember that density is mass over a volume, the density, the mass has to be in kilograms and volume has to be in meter cube. So the formula of density is kilogram per meter cube. So in order to measure the density of the substance, you should have the mass and the volume. So for example, if you are given this cuboid of the length, width, and height, 3 meter, 2 meter, and 6 meters, the volume would be length times width times height, which gives us 6 times 3, 18 times 36 centimeter cube. Now you need to convert this centimeter cube over meter cube, so you divide it by 100,000. So that will give you 36 times 10 power minus 6 meter cube density, the volume, and the mass of the object is 200 grams, which is 0.2. So to find the density of this substance, we will be doing mass over a volume. So it is 0.2 kilograms divided by the volume, which is 36 times 10 to the power minus 6. And when we do that, we will get the answer as 5.5 times 10 to the power 3 kilograms per meter cube. Okay, so in order to measure the density of the substance, we first find the mass, we find the volume. The mass has to be in kilograms and the volume has to be in meter cube. For the conversion, meter to centimeter, you times by 100, centimeter to meter, you divide by 100. Here it was cube. So centimeter cube is divided by 100 cube. And kilograms to grams, it's times by 1000 divided by 1000. Now this example is of a regular object. Now regular object means for which you can measure the length, width, and height and find the volume. Now we can have some irregular object like this. For that, how do we measure the mass and the volume? For the mass, you can use the weighing scale. For the volume, we will put it inside the water and we will see how much water this has displaced. So the change in the water level will be the volume of this substance, and we can do density as mass over a volume. So you should know how we measure the density of a regular object and also for an irregular object. Now let us look at what are the different states of matter. So this is just a brush up from your chemistry. So in solid, you can see that the particles are very close to each other. In liquids, they are slightly closer, and in the gases, they are further distance apart. The solids have a fixed shape, liquids do not have a fixed shape, and gases do not have a fixed shape. The solids have strong forces between the particles, liquids have weak forces between the particles, and gases have very weak forces between the particles. Solids have definite volume, liquids have fixed volume, gases do not have fixed volume at all. Solids cannot be compressed, liquids can be compressed, and gases are highly compressible. The solids cannot flow, liquids can flow, and the gases can flow. And when you convert solid to liquid, you are melting it, and liquid to gas, you are evaporating it. A gas to a liquid is condensation, and liquid to a solid is freezing. Okay, so I hope these states of matter are clear to you. Now let us look at what are the changes of state. How does a change of state take place? So when you have a solid, the temperature is increased. And as soon as it reaches the melting point of the solid, which is like 0 degrees, it is the temperature at which the solid changes into a liquid. So at that point, you will see your graph getting flattened. Here, the temperature is not increasing, but all the solids are converting into liquid. Now, this is the temperature where the temperature is constant, but heat is still taken up, and this is known as a latent heat. Then the liquid temperature slightly increases, and as soon as it reaches the boiling point, the liquid starts to get boiled into a gas, and the temperature remains the same until all the liquid boils up and converts into a gas. So here the temperature is constant until all the liquid is evaporated, and this is the boiling point at which the liquid turns into a gas. And here the heat that is taken up by all the particles without the change in the temperature is the latent heat. So this is the latent heat of fusion, and this is the latent heat of vaporization. We'll see next the concept in detail about the latent heat. Now, whenever you change the temperature, whenever you change the state, there's a change in internal energy. Now, you should know what is internal energies and what are the factors it depends on. So, internal energy is the total energy stored in the particle of the substance, and it is kinetic energy and potential energy. Kinetic energy is the energy due to the motion of the particles, and potential energy is energy due to the position of the particle. And internal energy is the sum of kinetic energy plus potential energy. Now, change of states involves heating or freezing, which results in change in internal energy of the system. When we increase the temperature, it results in increase in kinetic energy of the particle, and change in states result in change in potential energy store of the particle. When the solid is heated, the particles gain enough kinetic energy to break the solid force of attraction between the particles, and they move at a distance, changing the state to a liquid. And when a liquid is heated, the particle gains enough kinetic energy to break the force of attraction between the particles and move further away and change into a gas phase. Okay, so this concept of internal energy is clear to you. Now let us look at what is specific heat capacity. Specific heat capacity is the energy required to raise the temperature of a 1 kilogram of a substance by 1 degree. So the heat energy that will change the temperature depends on mass of the substance, the specific heat, and the temperature change. For example, calculate the heat energy transferred to heat 100 grams of water to 20 to 40 degrees. So what is the temperature change? 40 minus 20, 20 degrees centigrade. What is the mass of water? 100 grams. Remember, it has to be in kilograms, so that becomes 0.1 kgs. And the specific heat capacity of water is 4200 joules per kilogram per Celsius. So the heat energy is 0.1 times 4200 times 20. So that is 8400 joules of energy is being transferred. Now, if you know the heat energy by a joule meter and you know the mass of the substance and a temperature change, we can rearrange this formula as specific heat is equal to heat divided by mass and change in temperature, and we can find the heat energy or the specific heat capacity of any substance. So they can ask you in a practical, how can you measure the specific heat? So you need to talk about what are the apparatus you would use and how would you rearrange this formula. Okay, next is latent heat. If you see this figure, it explains the concept of latent heat. When a solid is converting into liquid, the latent heat of melting is absorbed, and when liquid is converting into gas, the latent heat of vaporization is absorbed. But on the other hand, the latent heat is released in condensation, and in fusion, the latent heat is also released. So what is latent heat? It is the energy absorbed or released without the change in temperature. At the melting point, the solid melts into a liquid. The temperature remains constant until all the solid converts into a liquid. This heat energy absorbed by the solid is latent heat of fusion. So latent heat is energy in joules divided by mass. Latent heat of fusion is the energy required to melt 1 kg of a solid into a liquid without the change in temperature. And latent heat of vaporization is energy in joules divided by mass. So latent heat of vaporization is the energy released to vaporize 1 kg of a liquid into gas without the change in temperature. Okay, so now the last concept, the pressure in a gas. Now, the gas pressure increases with temperature. This is the concept, and why? The reason is when we increase the temperature, the particle gains more kinetic energy, and it's not just the kinetic energy, it is the velocity of the particles also increases, so they collide more with the walls, increasing the gas pressure. And on the other hand, pressure and volumes are inversely proportional. If you decrease the volume, the pressure increases. So you can see in this figure, we have decreased the volume. Now, when we have decreased the volume, what happens? With decreasing in volume, remember the temperature has to be fixed and the amount of the gas should be fixed. This is a condition. The particles has less room. Therefore, they collide more, they bump with the walls more, they bump with the particles more, increasing the gas pressure. So the Boyle's law says that pressure times volume is constant. Okay, so I hope this relationship of pressure and volume and the pressure and temperature is clear to you. Okay, so I hope you have understood this unit. Now let us look at the key terms which you should know now. Density, solid, liquids, gas, melting, freezing, vaporizing, sublimation, melting point, boiling point, freezing point, latent heat of fusion, latent heat of vaporization, specific heat capacity, internal energy, pressure, and Boyle's law. Okay, so I hope all these key terms are clear to you. Pause this video, have a go at the key terms, and then come back and check your answer. Okay, so as always, what's the next step? The next step is check the specification, make sure everything which is mentioned in this topic is clear to you, and do the exam questions on this topic, which you can find on my website. I hope this topic is clear to you. If you still have any doubts, leave a comment below or come to our website where we have a 24/7 chat support till your exams. If you like this video, then do subscribe to our channel and do not forget to like, comment, and share this video. I'll see you next in the next video. Till then, happy revising.